Hello and welcome back. This is a section over 11.2, and this is one of my favorite sections. And what we're going to be doing is we're going to be factoring trinomials of the form x squared plus bx plus c. Okay? And so let's go ahead and let's talk about what happens when to factor these. Now, what we have to do is we have to remember multiplying binomials using either the FOIL or box method. So let's just think of a pretty easy one. Let's do, say, x plus 4 times x plus 5. All right. So when I multiply these out using the FOIL method, do my first ones first. And so I've got x squared. My outside ones, so 5 times x is plus 5x. 4 times x is plus 4x. And then multiply this out. 4 times 5 gives me plus 20. So we end up getting x squared plus 9x plus 20. Okay, this way means that we were multiplying. Okay, and really remember what we're doing is we're really doing the distributive property. The distribute. Okay, multiply slash distribute or distribute. All right, now what we're doing, our objective is for us to go backwards, okay? And that means to factor, all right? And that's the essence of what we're doing in this chapter, or in this section, okay? So if I were to factor this, okay, what I would want to think about, and the cool thing about this section is that this occurs when my leading coefficient is 1, all right? So what I want to think about when I factor the polynomial x squared plus 9x plus 20, I ask myself the question, what two numbers multiply to 20, okay, my last term, but add to 9, my middle term, okay? And so what I think about is this. I say, okay, well, those two numbers are going to be 4 and 5. Okay, when I multiply them, we get 20. But if I add them, so if we multiply, we get 20. But if we add, we get 9. Okay, and so simply what I do, because those are my two numbers, I could factor this, and I would end up getting just x plus 4 times x plus 5. Okay, and that's what I'm doing. So I'm starting here for this section, and we're going this way. This means to factor. Okay, if we go the other way to check, that means that we multiply, okay, to get there. All right, so factor, we're really just, it's the opposite of the distributive property, and so it's the opposite of foiling. So when you multiply this all out, okay, using the FOIL method, then, that's distributing, essentially. Okay, but when I factor this, that means that we're going backwards, all right? Now let's do the same problem, but let's use the box method on this. Okay, so let's think about, do x plus 4 times x plus 5. And so if I did the box method here, all right, then what I would do is I'm going to do x plus 4, x plus 5, x times x is x squared, 4 times x is 4x, 5 times x is 5x, and then 4 times 5 is 20. Okay, when I add these together, I'm going to get 9x, so we're going to get x squared plus 9x and then plus 20. Okay, again, this way we are multiplying. Okay, but what I want to do is I want to factor. Okay, so if I factor this using the box method, okay, factor in the box method, what I'm going to do is this. Okay, if I start with x squared plus 9x plus 20, I'm going to draw my box, and what I'm going to do is I'm going to look at my first term, x squared, is going to go in this box. Okay, so x squared is going to go here. And then my last term, 20, is going to go in this box down here. Now what I have to figure out is as I start asking myself the questions, okay, what times what is going to give me x squared? And that's just simply going to be x and then x. Okay, not too bad. Then what I want to do is I want to say, all right, well, let's look at 20. What two numbers are going to multiply to 20? What two numbers could I put here and here? And the cool thing about this is you can kind of do guess and check with this, but to have that also that intuitive sense of, okay, they also need to add to 9 once I do that, then that kind of helps us narrow down the options. So if I put a +4 here and put a +5 here, then what I can do is I can say, all right, if I do 5 times x, that's just going to give me 5x. If I do 4 times x, it's going to give me 4x. All right, so then if I combine these together and add them, that's going to give me a 9x, which is what I was looking for here, and we're good. So then what I do is I just write out my factors. These are my factors. So I just do x plus 4 and then x plus 5. All right. And this is kind of a method that either one is going to work. It doesn't matter to me. But I find that in other classes that you'll take, going forth, like Math 055, when you're asked to do a lot of factoring, the box method is really helpful to do that. Okay. So just kind of something you probably want to think about. All right. Now, the thing I want to do here is this. All right, let's go ahead and just factor all these trinomials. And what I'm going to do is I'm going to do the box method, all right, for each of these. And so let's go ahead. I'm going to put my first term, x squared, put that here. I'm going to put my last term, 6, over here. Okay, now I got to think. Two numbers that multiply to x squared is just going to give me x and x. Two numbers that multiply to 6 is probably going to be 2 and 3, all right? And we also have to think, okay, those numbers need to multiply or add to 5, all right? So this is going to give me a +2 here and a +3, all right? Now, if I take these two numbers, they'll multiply to 6. But let's do 3 times x, so we can check it and do 3x, and then I can do 2 times x, which is 2x. Now, if I add those together, okay, that's going to give me 5x, which is what I was looking for as my middle term. So, my factors then is just going to give me x plus 2 and then x plus 3, and we're done. Now, we can check by multiplying this out, but we've kind of already done that with the box method, and that's kind of why I like the box method, okay? All right, so now let's take a look at this one. This one gets a little trickier. Let's, again, just draw a box. So I've got y squared minus 8y plus 12. And so if I draw my box, my y squared goes here. Okay, my 12 goes down here. Now, two numbers that multiply to y squared is just going to give me y and y. Now, two numbers, this is where it's going to get tricky. Okay, I have two numbers that need to multiply to 12, but they need to add to -8. All right, so here's where this gets a little tricky. And what I want to do, first of all, what I have to think about is that both of these numbers that are going to multiply to 12 have to both be negative. And then they also have to add to -8. So let's do this. Let's just try like let's try -3 and -4. All right. So if I do that, I'm going to get -4y and I'm going to get -3y. Okay. Now when I add these together, this gives me -7y. Okay, which is not 8y, not -8y. Okay, so this is wrong. All right, and so what I need to do, and that's a cool thing about this, is you can kind of just guess and check. All right, so now let's try this again. All right, let's draw another box. All right, and I'm going to put my y squared here. I'm going to put my 12 here. I've got y here, y here. All right, let's try something else. Let's try 2 and 6. But let's do -2 and -6, okay? And the cool thing about that is that -2 times y is -2y, all right? -6 times y is -6y. If I add these together, that's going to give me -8y, which is what we were looking for here, okay? And so now this is correct. All right, and I factored that correctly. So all I just need to do is write it out as y minus 2 and then y minus 6, and we're good. Okay, and that's my answer. All right, let's take a look over here at this one. Now, these do get a little trickier, just kind of thinking of the numbers. So let's draw my box. All right, let me put in my x squared term here and then negative 20 down here. Two numbers that multiply to x squared is just going to give me x and x. Okay, now here's the tricky part, is coming up with two numbers that are going to multiply to negative 20, all right, but add to negative 8. So when I think about this, I think of the factors of 20, all right, and let's just kind of list those out, all right. So for 20, my factors are going to be 1, 2, 4, 5, 10, and 20. Okay, and you're probably already thinking, okay, if I do 4 and 5, that'll give me 20. But is there a way for you to add these either with positive or negative numbers that are going to give you negative 8? Okay, and this doesn't work. Okay, it's not going to happen, so no. All right, but let's look at 2 and 10. This will work. Now, what you have to think about is you have to get negative 8 when you add them. So what you have to do is think, okay, if I start off with negative 10 and I put a plus 2 down here, then that should work. So if I take x times negative 10, all right, that's going to give me negative 10x. If I take 2 times x, that's going to give me a positive 2x. And when I add these together, that's going to give me a negative 8x, which is what we were looking for. All right? So then this is going to factor to then x minus 10 times x plus 2. And that's my answer. Okay? So you do have to kind of think about these a little bit. They're not going to be something that automatically comes to you. Now, the more you do, the more you practice this, the more problems that you do, the more you're able to see these patterns and to be able to do this. Now, so there are times when I don't need to use the box method and I can just think about it and look at it and factor it. Okay, but then there are times when these polynomials can get a little tricky and I have to use the box method in order to factor that. Okay. All right, let's take a look at this last one over here. X squared minus 5x minus 24. Let's make our box. And so for here, I've got x squared and I've got negative 24. So x squared goes here, negative 24 goes down here. So this is going to be x times x gives me x squared. And then two numbers that multiply to 24, negative 24, but add to negative 5. Okay, in 24, what I'm going to do is I'm going to do 8 and 3. So 8 and 3 is a combination that can give me 5. Now, I got to be careful. So I got to get negative 5 out of that. So I'm going to do negative 8 and then plus 3. Okay, if I do negative 8 times x, it's going to give me negative 8x. 3 times x is positive 3x. If I add these two together, that's going to give me negative 5x, and that's what I'm looking for, and we're done. Okay, so then my factored form is just going to give me x minus 8 and then x plus 3, and that's my answer. Okay? All right. Let's take a look at these down here. Now, these are going to get a little tricky. Now, the first thing I want to notice here is that this is out of order. Okay, this is not in standard form. What I want to do first on this one is reorder it. So I'm going to write this as t squared plus 5t and then minus 24. Now, notice that these are the same, very similar numbers to what we had in the last problem. But what I want to do here is I'm going to draw my box. Okay, I'm going to put t squared here, negative 24 in my last box. And the reason why I did this, guys, is because your constant value should always be at the very, very end. Okay, so now let's write this as t times t, and then negative 24. Now, we still have to multiply to negative 24, but we have to add to positive 5. So we have to switch these. So this is really going to become plus 8. And this down here is going to be minus 3. So if I do negative 3 times t, that's going to give me negative 3t. 8 times t is going to give me positive 8t. Now when I add these together, 8t minus 3t is going to give me a positive 5t, and that's what we're looking for. So this factors to t plus 8 and then t minus 3, And that's it. That's all we're doing. Okay? All right, now let's take a look at this one. Ugh. This one is very confusing. Now, what you notice here is that we still have a trinomial here. All right? And what I like to do is I like to rewrite this. I can rewrite x to the fourth as the quantity x squared minus then an x squared minus 110. Okay, so what I'm doing on this one is, I rewrote this to kind of show a pattern here, to show you something that I can do to make this a little bit more manageable. And so, as long as I rewrite this and I could go back and, x squared, I'd multiply my exponents, it gives me x to the fourth, we're good, you can do that. What I want to do here is something called a U substitution. All right, so watch what I do here. I'm on this because what this is this is just a little bit confusing. Okay, it kind of looks like a quadratic or a trinomial. It is a trinomial, but we've got a degree 4 here. All right, so it's a little bit trickier. And what I want to do is I want to let u equal x squared. So wherever I had an x squared, I want to replace that with a u because that's what x squared is equal to. Okay, now I'm creating this. All right, so what I would do here is I would write this then, instead of writing x squared, I would write this as u squared minus u minus 110. Okay, now what I have is a familiar thing that I could factor. All right, so let's do the box method on this. So for this, what I'd want to do, same thing, I'm going to put u squared in this first one. I'm going to put negative 110 over here. Now to get u squared, I'm going to do u times u. And then what I'm going to do is I need to think about two numbers that are going to multiply to negative 110 but add to negative 1. And what that's going to give me is 10 and 11. All right, because those somehow they'll add to negative 1. All right, so what I want to do here is I want to think, okay, if I make this top part negative 11 and make this bottom part over here positive 10, all right, then I can do 10 times u, which gives me positive 10u, and then negative 11u here. Now, if I combine these together, this is going to give me just a negative u, which is what we're looking for here. All right, so this is factored, okay? And I've got u minus 11 and then times u plus 10. But remember that we had this original problem was in terms of x. So what I have to now do is take these values here for u and re-plug back in my x squared. So here's what I end up getting. All right, so this is going to give me x squared minus 11 and then times x squared plus 10. And that's my answer. Okay, so it is a little bit tricky. Now you could also just do, and put this in as x squared, and you don't have to do the u substitution. You don't have to do it that way. For me, this always was something that made sense. Okay, it was to do the u substitution and to plug that back in. Okay, so all I'm doing is rewriting this and putting it into terms that are something that are easy for me to do, and then go back and resubstitute x squared in for u. Okay, so it doesn't really matter, but that's one way of doing it. All right. Okay, let's take a look at this one. Now, sometimes these problems might not factor. Okay, and it doesn't matter what you would do to get them to factor. So my first term, x squared, goes in this box. Okay, my last term, 5, goes in this box. All right, and so I got to think, okay, what two numbers can I multiply to give me x squared? This is going to give me x and x. Okay, and then I got to think about two numbers that are going to multiply to 5, but they also need to add to negative 1. All right, so if I think about this, I'm like, all right, well, if they both need to be positive, then I need to, do negative 1 and negative 5. Okay, so if I multiply those together, I'm going to get negative 5x and then a negative x here, and that's going to give me a total of negative 6x, which is not negative x, so this is wrong. Okay, now what you have to think about is, all right, in order for me to get a negative number as my middle term, and a positive number here, both of these numbers have to be negative. Well, and the problem is that 5, if I factor 5, that's only 1 and 5. Okay, 5 is a prime number. So those are the only numbers that I could use to factor this, but it doesn't factor to anything. Okay, I can't actually factor this, which is kind of terrible. So what I end up doing is I say that because if it doesn't factor, then the polynomial, polynomial is what we call prime. All right? And so if it doesn't factor, then we simply just write the word, it's a prime polynomial, and it doesn't factor. Okay, so that means that it doesn't factor. All right? And that's that. All right, let's take a look at the very last one. And this is where things can get a little confusing, because you might look at this and you're like, ugh, I don't have a thing to do for something that's x cubed with 3 terms. Okay, in the other video we could have done factor by grouping, but we don't have that extra term here. So what I want to do is say, okay, is there anything I could factor out of each of these terms? And what I could factor out of here is a 2x. And that would leave me with x squared minus 10x and then plus 25. All right, and when I do that, what I want to do then is then factor this. All right, and just that quantity, that quadratic or the trinomial. So now I do the box method here. All right, I'm going to put x squared in my first box, put a 25 in my last box. And so now what I can do is I can say, all right, x times x gives me x squared. And then two numbers that multiply to 25, but also add to negative 10, would give me negative 5 and negative 5. All right, and so on here, what I've done is I factored this. But we have to remember to keep the 2x, okay? So that's going to come down, and we've got 2x multiplied by x minus 5 by x minus 5, okay? And when I have, two of the same thing, x minus 5 and x minus 5, I simply just can write that as 2x times x minus 5 quantity squared. And that's it, all right? So, all this stuff, and let me do this. Let me make sure that this is factored correctly. I need to do negative 5x, combine these. It's going to give me negative 10x, which is what we were looking for here, so we're good, and that's factored. So this is one of my favorite chapters because I got really good at doing this when I was learning it first. And it is something that I have done in every single math class that I have ever taken. Factoring is very important, okay? And I think it's kind of fun to do this. It's kind of like a little puzzle. The more you do, the better you get. So here's your homework. Go ahead and get started, and we'll see you in a bit. Thanks. Bye.